Ever been stuck in traffic, late for work, coffee cold, patience gone? It's a daily struggle for millions, inching forward while the clock ticks mercilessly on. The frustration builds, and you wonder if there's any escape from this endless sea of brake lights. Then you spot it. An elevated road soaring above the chaos. It's like a secret passageway, a lifeline for those lucky enough to reach it. You take the ramp, and suddenly, you're gliding over the gridlock. The world below seems to slow down as you move swiftly above it all, leaving the honking and frustration behind. That's a flyover, a marvel of engineering we rarely think about, but rely on every day. It's more than just concrete and steel. It's a silent promise of smoother journeys. These silent giants keep our cities moving, working tirelessly above the busiest intersections. They're the unsung heroes, quietly making life easier for everyone below. But who builds them? How do they rise above the city? What does it take to create these massive structures that seem to defy gravity? Behind every flyover is a story of planning, power, and hard work. It starts long before the first beam is set in place, with teams of experts mapping out every detail. From engineers drafting blueprints to welders braving dizzying heights, every role is crucial. Each person brings unique skills, dedication, and courage to the project. Building a flyover isn't just pouring concrete, it's solving a massive real-world puzzle. Every piece must fit perfectly, every calculation must be exact, or the whole structure is at risk. Let's pull back the curtain and see how these feats of engineering come to life. The process is long, complex, and filled with challenges at every turn. Imagine thousands of tons of concrete and steel, lifted high while the city buzzes below. It's a balancing act requiring precision, teamwork, and nerves of steel. It's not magic, it's a dance of people and machines, grit and precision. Every movement is choreographed, every action matters. So next time you soar over a jam, take a second to appreciate the story beneath your wheels. Remember the hands and minds that made your smooth ride possible. We're about to get our hands dirty and explore the epic process of building a modern flyover. From the first shovel of dirt to the final bolt, every step is an adventure. This is where the real action happens, where concrete is poured and steel is welded. It's the heart of the operation, where vision becomes reality. It's a dirty, dangerous, and vital job. Let's get started. The journey from blueprint to bridge is about to begin. So what is a flyover? You've probably seen them soaring above city streets, but have you ever wondered what really goes into these impressive structures? It's a bridge that lets one road soar over another, untangling traffic and keeping cities moving. By separating traffic streams, flyovers help vehicles avoid intersections and delays, making commutes faster and more efficient. Its purpose: eliminate conflict points, reduce congestion, and make roads safer for everyone. With fewer stops and starts, there's less chance for accidents and bottlenecks. Think of it as an express lane in the sky, lifting you above the chaos below and giving you a smoother ride. The main parts: foundation, piers, and superstructure. Each plays a unique role in holding up the bridge and supporting the weight of traffic. The foundation is the deep anchor, like the roots of a tree, buried underground to keep everything stable, even when thousands of vehicles pass overhead. Piers are the tall supports, the legs of the structure. They rise up from the foundation, holding the bridge high above the ground and giving it strength. The superstructure is the deck you drive on, supported by beams and barriers. It's the visible part, stretching across the gap and carrying the load of traffic. Imagine building with Legos. The base plate is your foundation, stacks of bricks are piers, and the long flat pieces are the superstructure. Each piece must fit perfectly for the whole thing to work. But real flyovers face immense weight, harsh weather, and constant vibration from traffic. They must be engineered to withstand decades of use in the forces of nature. Every piece must be perfectly designed and executed to last decades. Even a small flaw can lead to big problems down the road. The foundation transfers weight to the earth, piers carry the load, and the superstructure spans the gap, working together as a single unified system. It's a system of interconnected parts, each with a critical job. If one part fails, the whole structure is at risk. Understanding these basics is the first step to appreciating the work behind every flyover. There's a world of planning, design, and teamwork behind every bridge you cross. It's not just concrete, it's a testament to human ingenuity, creativity, and the drive to solve complex problems. A man-made mountain range, built to keep you moving, connecting neighborhoods, cities, and people. Next, let's see how it all begins. The journey from blueprint to reality is just as fascinating as the finished structure. The real magic starts with a plan, where vision, engineering, and teamwork come together to shape the future of our cities. Before construction, a flyover's life begins on screens and blueprints. The planning phase can take years and involves civil engineers, urban planners, geologists, and more. Where is it needed? What path will it take? How will it affect the city? Teams survey the land, study traffic, and test soil to ensure the ground can support millions of pounds. Using advanced CAD software, engineers create a digital twin, testing every stress from wind to earthquakes. Every nut, bolt, and bar is specified in these plans. Public consultations gather community feedback, and planners coordinate detours and utility moves. It's a logistical puzzle, one that must fit seamlessly into the city. The hard work in the office ensures construction chaos is controlled and safe. A well-designed flyover is more than strong, it's built to minimize disruption. The blueprint is the unsung hero, guiding every step to come. Now let's break ground. With detailed plans in hand, it's time for boots on the ground. Site preparation begins in earnest, marking the true start of the project. In the heart of a bustling city, clearing the way means more than just removing old structures. It involves demolishing existing buildings, rerouting traffic, and carefully excavating around a complex maze of underground utilities that keep the city running. Crews rely on advanced ground-penetrating radar and detailed utility maps to avoid hitting vital water mains, gas lines, or fiber optic cables. Mistakes here can mean costly delays and dangerous accidents. Once these hidden lifelines are identified, utilities are carefully relocated, a massive, intricate job on its own that requires coordination and precision. Meanwhile, traffic management kicks in. Cones, barriers, and detour signs become the new normal for commuters as the city adapts to the changing landscape. Heavy machinery moves in to level the ground and dig deep for the foundations, transforming uneven terrain into a buildable surface. Sometimes the soil isn't strong enough to support massive structures. Engineers test its stability, then mix in special materials or compact it with heavy rollers until it's rock solid and ready for construction. This phase is loud, dusty, and muddy. Workers in high-visibility gear brave the elements, knowing this messy work is the bedrock of the entire project. Think of it as preparing the canvas before painting a masterpiece. Every detail matters because what comes next depends on this foundation. If the ground isn't right, nothing else will be. A weak foundation can doom even the best designs, making this step absolutely critical. Site prep is about creating a stable, secure environment for what's to come, ensuring the future structure stands strong for decades. It's a battle against obstacles, both seen and unseen. Unexpected pipes, rocks, or even old foundations can appear, demanding quick thinking and teamwork. Only after all this groundwork is complete does the real building begin, as the first concrete is poured and the structure starts to rise. With the ground ready, it's time to build the hidden strength, the foundations. The entire weight of the flyover is channeled through piers into these deep anchors, the most common method piling, driving or drilling long columns of concrete and steel deep into the earth. Driven piles are hammered in, board piles are drilled, caged with steel, and filled with concrete. For a large flyover, this means dozens or hundreds of piles, each perfectly placed. On top, a massive pile cap ties them together, forming a solid base for the piers. Crews work in trenches, battling mud and groundwater, handling tons of steel and concrete. Pouring must be flawless. No air pockets, no weak spots. The foundation is the flyover's anchor, buried deep, unseen but essential. If this step fails, everything else crumbles. With the bones set, it's time to rise above ground. With foundations set, the flyover starts to rise. Piers first, then the superstructure. Crews build formwork molds, assemble steel rebar skeletons, and pour concrete for each pier. After curing, the formwork is stripped, revealing strong concrete columns. Next comes the dramatic part, lifting massive girders, made off-site for quality and speed. These beams, sometimes over 100 feet long, are transported and hoisted by giant cranes. The lift is a high-stakes ballet. Crane operators and workers guide each girder into place atop the piers. Each segment is secured with heavy-duty bearings and bolts. This process, called segmental construction, repeats until the deck stretches across the gap. Piece by piece, the flyover takes shape above the city. It's a slow, nerve-wracking, and awe-inspiring dance of man and machine. The skeleton is up. Now it needs a surface. Next, we build the road in the sky. Let's deck it out. With girders in place, it's time to build the road deck. Precast panels or steel decking form the base, then a grid of steel rebar is laid for strength. A massive concrete pour creates the final driving surface, smooth, strong, and sloped for drainage. Before the surface is finished, crews install drainage pipes, electrical conduits, and wiring for lights and sensors. All these systems are hidden but vital for safe operation. Expansion joints are added, flexible gaps that let the bridge expand and contract with temperature changes. Without them, the structure would crack and fail. These details ensure the flyover lasts for decades. The deck is more than a road. It's a complex, engineered platform. Now it's time for the finishing touches. Let's make it safe, functional, and beautiful. The final phase is where it all comes together, almost ready for traffic. The structure is up, but it's not ready for cars yet. First, a waterproof membrane protects the deck from water and salt. Special asphalt is laid for a smooth, durable ride. Crews paint lane lines and arrows, turning blacktop into an organized roadway. Safety barriers are installed to prevent vehicles from going over the edge. Lighting poles go up, ensuring safe nighttime driving. Overhead signs guide drivers to their destinations. Landscaping and public art can transform the space beneath, blending the flyover into the city. These finishing touches ensure safety, function, and visual appeal. The flyover is now a complete piece of public infrastructure, ready for its first morning rush. Next time you drive over a flyover, see more than concrete. See years of planning, engineering, and hard work. It's a modern marvel built by skilled hands and sharp minds. Flyovers are more than traffic solutions. They're monuments to teamwork and ingenuity. Crews overcome obstacles, adapt, and innovate, all to keep cities moving. As cities grow, smarter, faster, and stronger flyovers will shape our future. Prefabrication and advanced sensors are making construction safer and more efficient. The story of a flyover is a human story of grit, collaboration, and building a better world. So, give a nod to that concrete giant next time you pass by. It stands strong because good people got their hands dirty to build it. That's a job worth celebrating.